welcome friends to my channel. Now on last lecture I have discussed about the relations among the elastic constant. Now one thing I forgot to tell that besides four elastic constant there exists another elastic constant. Okay, that I forgot to tell, and that another elastic constant is known as axial modulus. That is called axial modulus and denoted by chi. So what is it? The definition of axial modulus is that is simply it is also in the form of stress by strain. Here the definition is applied force per unit area in a particular direction. In a particular direction, the increase in length per unit length, while strains along other two directions are prevented. This is the definition of axial modulus. That means we can apply a force per unit area, that is stress, in a particular direction so that strain will also takes place in that particular direction. This means along two other perpendicular directions the strains are prevented. We have to ignore the strains in two other perpendicular directions. Okay, so let us take an example. Okay, now suppose we draw a cube of unit length. Okay, suppose we draw cube of unit length, say whose three sides are coincides with the coordinate axis. Okay, three sides are coincides with the coordinate axis. Okay, suppose we apply tensile force per unit area along x-axis. Okay, tensile force per unit area P along x-axis. Okay, so obviously due to this force the cube will be elongated along x-axis and contracted along y and z-axis. Okay, so elongation along x-axis is this and contraction along y-axis is this. So we can clearly see that contraction takes place along y and z-axis. Okay, but we have to adjust the strains in two directions in such a way that the strains along these two directions are cancelled. That means we apply force along each direction. So we only count the stress and strains in each direction. Y and Z strains we ignore that. So we see that contraction takes place along y and z axis. So we must have to nullify it. How? If we apply another tensile force, say P dash, along these two axes, then what happens? If we apply another tensile force P dash per unit area along y and z axis, then what happens? Due to this force, the cube will be elongated along y-axis, y and z-axis. Okay, since we apply another tensile force per unit area P dash along y and z-axis, okay, due to that forces the elongation takes place along y and z axis. So contraction will take place. Okay, result. Okay, this is the result of these different forces acting along the three sides. Okay, now what will be the net extension along x-axis? Net extension along x-axis, just give it a name, say E. This is what? P by y minus 2 sigma P dash by y. Okay, now if we look back into the definition, then the definition is applied force per unit area in a given direction to the increasing length per unit length in the same direction. Okay, while strains along other two directions are prevented. That means initially we apply stress along x direction. That means we only take the strain along x direction. That is, strains along y and z directions are prevented. So at first let's see what is the strain along y and z direction. Okay, so the strain along y direction is P dash by y minus sigma P dash by y minus sigma P by y, and that strain along z direction, this is also same quantity, P dash by y minus sigma P dash by y minus sigma P by y. Now strains along other two directions are prevented. That means this term make equal to 0, this term we can set equal to 0, and both are same terms. Okay, so no problem, both are same terms. So if we set this term 0, then what we get? This. So we can express P dash in terms of P. Okay, so this is the value of P dash. By setting the strains along y and z axis equal to 0, we can get P dash is this. So if we put the value of P dash in E, so what will be the strain along x axis? 2 sigma P dash, that means into sigma P by 1 minus sigma. Okay, so if we take P by y common, so this is simply 1 minus 2 sigma square by 1 minus sigma. Okay, so this is simply P by y, and this is 1 minus sigma minus 2 sigma square by 1 minus sigma. Okay, so if we factorize it, this becomes this 1 minus 2 sigma into 1 plus sigma by 1 minus sigma. Okay, so this is the value of P. Now what will be the axial modulus along x-axis? That is applied force per unit area along x-axis P divided by strain, that is P by E. So what will be my P by E? My P by E will be y into 1 minus sigma by 1 minus 2 sigma into 1 plus sigma. Okay. Now again we know another relation that y equals to 3k 1 minus 2 sigma. Okay, so this is 1 minus 2 sigma and this is 1 plus sigma. So this cancels. Okay, so and again we can write sigma in terms of k and eta. That means sigma means 3k minus 2 eta by 6k plus 2 eta, and again this can be written as 3k minus 2 eta by 6k plus 2 eta. Okay, so this is simply 3k, this is 3k plus 4 eta, 3k plus 4 eta, and this is 9k. So this is simply 1/3 3k plus 4 eta. That means we can easily write chi this equals to k plus 4/3 eta. So this is the relation between axial modulus, rigidity modulus and Bach modulus. Okay, so in today's lecture I discuss about the axial modulus and its connection with other elastic constant. In my next lecture I shall going to discuss about the torsion of cylinder. So if you like this video then kindly subscribe my channel. Okay, thank you.